My name is Carl Higby. Last name spelled H-I-G-B-Y.
Carl with a C or a K?
With a C.
Okay.
Terrific. Okay. Why don't you just tell us, how you came, when you came to Hanford, and then you can.
Well, in 1950, when I graduated at Washington State University, a recruiter was visiting the WSU campus and made a job offer. It turns out that was the only job offer I got, so I came here. Had to wait after graduation until I received my security clearance. That was an essential first step. And that came through, and I arrived here on my birthday in July 1950.
And talk about your baptism under fire.
Well, I had undergone training for an operations supervisor at all the old B-type reactors. And when I became an operating supervisor, on the very first shift that I was alone as the operating supervisor, about midway through the shift, we received a weak radiation signal in the effluent water. And it was too weak to be able to identify which tube contained the leaking fuel element, so we had to wait for a while until the signal became stronger. The radiation monitor was taking water samples every few minutes, and finally, after about 2 hours of operating with this ruptured fuel element, we were able to confirm that we had a ruptured fuel element. So then we shut the reactor down and diverted the flow stream, the coolant water flow stream, to a big ditch to receive the radioactive water. That kept it out of the Columbia River, and proceeded to discharge the ruptured fuel element. But our attempts to discharge it by flushing or by pushing from the front were not successful. We had to then insert a new process tube from the front. We removed the nozzles first and pushed the tube containing all of the fuel plus the ruptured fuel element out the rear face and into the reactor. This took a couple of days with everybody wearing fresh air masks and full-suited protective clothing with the coveralls taped to gloves and rubber boots. And as time went on, we became a little more adept at handling these stuck ruptures, developed better methods and better tools, and it became just kind of a fact of life. But each one took a couple of days to recover.
That's good. Have you, did you know that, was this common practice in the Manhattan Project as well, that people would have these incidents and it would take a couple days to recover?
When the old reactors were operating at their design power levels of 250 megawatts, I don't recall that there had been any ruptured fuel elements. But as the power levels were increased to meet Cold War needs, we started experiencing ruptures with greater frequency.
What about, and you're talking about the safety circuits? Maybe
Well,
talk about that system.
Each of the reactors had all of the essential parameters monitored by instruments which were connected to the safety circuits. Any abnormal reading on such things as the reactor neutron flux level or process tube outlet temperatures or cooling water low flow, these kinds of things would trigger a safety circuit trip and cause a scram. The scram, word scram, was an acronym for Safety Control Rod Axeman that originated from at the Chicago pile during the pre-reactor operating days. One of the greatest source of trips was the panellet gauges. There was a panellet gauge which monitored the flow rate to each of the process tubes. And either a high or low pressure reading on the panellet gauge would trip the safety circuit. This meant there were 2004 gauges, each with 2 possible trips that could give us a scram.
And those dated back to the Manhattan Project?
Yes, they did. Uh-huh.
And what's your sense of how well they worked?
They were quite reliable. We had instrument technicians on every shift who was able to keep them in calibration. And our operators also read all 2004 gauges at least once per shift. The one thing that did cause us trouble at times is a plugged sensing line, and this happened occasionally and required us to bypass the trip switches on the sensor and backflush the line to clear the pluggage.
And the pluggage would be caused by what kinds of things?
Oh, it was impurities in the water stream.
Let's see, you talk about the Ball 3X system. What is that?
Oh, okay. One of the things we were concerned about is the possibility that the horizontal safety rods and the vertical safety rods may not be capable of shutting the reactor down. In this case, each of the reactors was equipped with what they called a Ball 3X system. A hopper of boron steel balls was able to trip and drop these hopper balls into the reactor, fill up the vertical rod safety channel. The only thing that caused an automatic trip of the Ball 3X system was a seismoscope. I don't have any recollection of an actual earthquake having tripped any seismoscopes, but one time on my shift, we did have a situation where, the first thing that happened was we had a cast car. A locomotive came in to pick up a cast car loaded with fuel. And this was a normal operation, but about this time, the radiation monitoring supervisor came to me and he said that locomotive just drove that cast car into the stops with a hell of a crash. And about that time, my control room operator called and said, well, we just got a Ball 3X trip. I think the balls just went in. And our first reaction was to think that this locomotive had slammed the car into the stops and had caused a tremor that tripped the seismoscope. But what actually had happened, and we found this out later, was one of the coils on the seismoscope had burned out, and it allowed the trip relay to actuate. So then we had to vacuum the balls out of the channels. That was a big job.
How long did that take?
2 or 3 days, as I recall.
And how big are the balls?
They were about a ½ inch in diameter, as I recall.
Do you know if they were ever used during the Manhattan Project? Did they need to resort to them?
Well, the Manhattan Project preceded the Ball 3X system. They actually had a borax solution that was intended to be dumped into the reactor, but then after and my knowledge, there was never any cause for the borax solution to have been dumped into the pile. Dumping that stuff in there would have been catastrophic. It would have destroyed the reactor. I'm glad it never happened.
talk about inserting and removing splines and what that did? And you need to talk to Cindy when you give the answer.
Splines were used. I never witnessed their actual operation. I knew what they were. They were a little flat metal spline containing boron carbide crystalline powder that was inserted in the fuel channel under a column of fuel slugs. They were used to suppress the neutron flux in hot zones, particularly on the far side. When the horizontal control rods were withdrawn, that left very little poison on the far side of the reactor, so that the flux tended to concentrate over there and give us high graphite temperature readings. So by inserting the poison splines, that controlled the neutron flux a little better, flattened it.
Can you explain the term far side and near side?
Oh, okay. The near side of the reactor was called the near to the control room, and the control room, or the control rods, were inserted into the reactor from the near side, near the control room. So if it wasn't the near side, it was the far side.
You talk about radon cloud incident?
Yes, there is a phenomenon of naturally occurring radon gas occasionally forming clouds. I observed this quite by surprise one time. We were on graveyard shift. One of the men had been working on the wash pad decontaminating some tools. Left the wash pad getting ready to end the shift. This was before daylight, and we got a call in the control room. He says, send radiation monitoring here, I'm all crapped up. And the radiation monitor went out, surveyed the man to determine if he was indeed crapped up, and it turns out that all of the survey instruments in the building were off scale. It was a general condition. We found out the man himself was not contaminated. And my first thought was that we may have had a leaking seal and allowing the reactor atmosphere to escape into the building. And so the chief operator called the other reactor sites and determined that all of them were affected the same way. They all had their instruments off scale. Our radiation monitor was a pretty savvy guy, and he said, well, there's a possibility this is a radon cloud. And if so, it'll dissipate after the sun comes up. And sure enough, that's what happened. When the sun came up, all the readings went back to normal. And radon is still with us. In some areas, they have radon escaping from the ground, and it gets into houses. But it's not a problem in the Tri-Cities area.
So what do you attribute this radon?
It's a decay product from natural uranium.
But that's what it was, enough natural uranium in this area, in the reactor areas, to trigger this?
Somewhere in the continental United States, this radon escaped into the atmosphere and drifted over the Tri-Cities.